The history of the oil industry dates back several centuries, but its prominence as a major energy source began in the 19th century. Here are some key points about the industry's history, pioneers, uses, and its current status. Ancient times. Oil was used in ancient cultures for various purposes, including in lamps, for waterproofing boats, and medicinal purposes. Bitumen, a form of petroleum, was used in ancient Mesopotamia and the Middle East for construction and as a sealant. 18th and early 19th centuries. In the 18th century, oil began to be used more formally, particularly for lighting in the form of kerosene lamps. Edwin Drake, often credited with drilling the first successful oil well in Titusville, Pennsylvania, in 1859. This event is generally considered the start of the modern oil industry. John D. Rockefeller, founder of the Standard Oil Company in 1870, Rockefeller played a crucial role in shaping the oil industry. His tactics and strategies in business led to the development of large-scale integrated oil companies. Present use of oil, growth, and expansion as an energy source. The oil industry expanded rapidly, with major discoveries in Texas, the Middle East, Russia, and other regions. Oil became a key component in transportation, especially with the advent of automobiles, airplanes, and ships. Currently, oil remains one of the main sources of energy worldwide. It is used extensively in transportation, heating, electricity generation, and as a raw material in the chemical industry. As of recent data, oil accounts for about 31% of the global energy consumption. This number has been gradually decreasing as the world moves towards renewable energy sources, but oil still maintains a significant share due to its energy density and existing infrastructure. Creativity and bravery in the oil industry often manifest through innovative technologies, processes, and strategies that address both current challenges and future demands. Oil and gas exploration and production activities can differ significantly between onshore and offshore environments. Here are some key distinctions. 1. Location and accessibility. Onshore, these activities occur on land. Access is generally easier and logistics are simpler, with established infrastructure like roads and pipelines often available. Offshore, these activities take place beneath the ocean floor. They require transportation by sea and specialized facilities like platforms or floating vessels, making access more complex. 2. Infrastructure and cost. Onshore, infrastructure such as drilling rigs and production facilities can be installed on land, which tends to be less expensive and easier to maintain. Offshore, requires significant investment in platforms, subsea systems, and sometimes floating production storage to handle the challenging marine environment, leading to higher costs. 3. Technology and equipment. Onshore, uses conventional drilling technologies. The equipment is generally more straightforward compared to offshore. Offshore, requires specialized technology to address deeper water, high pressure, and potential subsea challenges, including dynamic positioning vessels and underwater remotely operated vehicles, ROVs. 4. Environmental and regulatory considerations. Onshore, potential environmental impacts include land disturbance and habitat disruption. Regulations may vary depending on the region. Offshore, stringent environmental and safety regulations due to the risks of spills and ecological damage. Dealing with harsh weather conditions and deep water pressures also needs careful planning. 5. Risk and safety. Onshore, risks include land subsidence and potential groundwater contamination. Safety protocols are relatively standardized. Offshore, higher operational risks due to rough seas and extreme weather. Safety concerns are amplified, requiring rigorous emergency preparedness measures. 6. Economic factors. Onshore, generally, lower operational costs make it economically attractive, especially for smaller reserves. Offshore, while discovery potential might be higher, the costs and economic risk are also significantly greater, often justified by large-scale reserves. Each type of operation has its own unique set of challenges and benefits, influencing decisions on where and how companies invest in exploration and production activities. Deciding whether an oil field is economical after discovery involves comprehensively evaluating various factors. Some key considerations include reservoir characteristics, assessing the size, depth, porosity, permeability, and pressure of the reservoir to estimate its potential oil and gas reserves. Production potential, analyzing the production rates, flow characteristics, and recovery factors to estimate the quantity of oil and gas that can be extracted economically. Oil price outlook, considering the current and projected oil prices to determine if the revenue generated from selling the extracted oil can cover the development and operating costs. Development costs, estimating the capital required to develop the oil field, including drilling wells, installing infrastructure, and implementing production facilities. Operating costs, evaluating the ongoing operational expenses such as maintenance, labor, utilities, and transportation costs associated with running the oil field. Regulatory environment, understanding the regulatory framework, including environmental regulations, taxation policies, and local laws that may impact the economics of developing the oil field. Technological feasibility, assessing the availability of advanced technologies and techniques that can improve the efficiency and cost-effectiveness of oil extraction. Risk analysis, conducting a risk assessment to identify and mitigate potential risks that could impact the economic viability of developing the oil field, such as geological uncertainties, market fluctuations, or political instability.